Bueno, pues bienvenidos todos al Museo Arqueológico Regional de la Comunidad de Madrid, aquí en Alcalá de Henares. Quiero comenzar por daros las gracias por vuestra asistencia. El hecho de que hayáis acudido masivamente demuestra que en España pues no solo interesan las cosas de entidad menor desde el punto de vista intelectual, que lo que va a suceder aquí esta tarde es un acontecimiento científico, académico, intelectual. Es evidente, creo que por eso estamos todos nosotros aquí. Os doy muy sinceramente las gracias. Repito, permitidme que resalte la presencia del alcalde de nuestra ciudad, de Javier, entre nosotros, es un asiduo, y de varios miembros del consistorio, lo cual agradezco mucho. También en representación de la obra social de la Caixa, que es nuestro patrocinador, gracias al cual hoy podemos contar con la figura de don Johansson entre nosotros, y también con algunos miembros de la comunidad científica, como es el propio profesor Arzuaga, que también nos acompaña, y muchos otros de vosotros que estoy viendo, pero que no puedo citar a todos. Sí quiero decir dos cosas muy brevemente sobre Donald Johansson. La primera es que tal vez no me he visto nunca en mi vida en un apuro semejante, porque jamás me había tocado presentar a la persona a la que más admiro en el planeta. Creo con toda franqueza que desde mi juventud, en que decidí dedicarme a la evolución humana, si algo hubo que impulsó y de manera absolutamente decidida esa voluntad, fue no tanto el descubrimiento de Lucy, del que ahora nos van a hablar extensamente, sino que fue pues, un verdadero acontecimiento, pero hubo todavía algo que multiplicó por mucho, exponencialmente, aquel descubrimiento que fue el primer libro de Donald Johansson sobre Lucy, que se publicó en el 79 y que en España se publicó en el 82. Fue una verdadera revolución. La publicación de ese libro fue una verdadera revolución que disparó las vocaciones en el campo de la paleontología, de la arqueología y de la evolución humana de una manera extraordinaria. Donald Johansson, desde entonces, creo que es la mayor celebridad en el campo de la investigación sobre evolución humana. Creo que Lucy, del que hoy vamos a hablar extensamente, en fin, representó un cambio absolutamente en la imagen social que se tenía de la evolución humana. A partir de los trabajos de Donald Johansson, la sociedad en general, el común de los mortales, empezó a interesarse por los temas que atañían a la evolución de nuestro grupo humano, de los Homo, y principalmente eso hizo que cambiaran muchos paradigmas. Pero él es injustamente conocido por su gran descubrimiento de Lucy, pero además digo injustamente porque tiene muchísimos otros trabajos y muchísimos otros descubrimientos que le han convertido en la celebridad científica y académica que es, y también social. Hay que decir que, bueno, es una persona a la que quieren los fósiles, como comentábamos hoy en el almuerzo, es una persona a la que quiere los fósiles y es un ser querido por los fósiles. Se han acompañado siempre algunos de los mejores fósiles que tenemos en el planeta y, por ejemplo, pues yo estoy pensando ahora en OH62, que es uno de los fósiles más importantes que se han descubierto en la garganta de Olduvai y que nos permitió ya en su momento, en el 86 creo recordar, que fue el momento del descubrimiento, cuando nos permitió en ese momento ya conocer lo que es el esqueleto postcraneal de Homo habilis, ¿no? El primer representante del género Homo que tan mal conocíamos hasta esa fecha. Bien, pues todo eso se debe en muy buena medida a los descubrimientos de Donald Johansson. Él es una persona formada en Chicago, con uno de sus profesores y mentores en ese momento fue Francis Clark Howell, un grandísimo paleoantropólogo que tanto tuvo que ver con la ciencia en España, porque trabajó muchos años en Torralba y sobre todo en Ambrona, pero que fue líder inicial a partir del año 68 en la operación en el río Omo, en Etiopía. Fue de los primeros investigadores en trabajar allí y a partir del 70, ya con la incorporación de un joven Donald Johansson y de otros grandes investigadores, se produce realmente la emergencia de ese proyecto que tanto cambió las líneas directrices de la evolución humana. En el Middle Aguas, en la región de los Safar, es donde se han producido desde entonces algunos de los más importantes descubrimientos en la evolución humana y confío y deseo fervientemente en que hoy nos hable don Johansson de todas estas cosas. No solo os diré que es una gran celebridad, celebrity que dicen ahora en el campo de la evolución humana, sino que sobre todo es una persona extraordinariamente afable, cordial y muy generosa. lo cual no siempre se lleva en este gremio nuestro. Y yo de esto quiero dejar hoy testimonio y agradecérselo muy sinceramente. Es la primera vez que contamos con la presencia de Donald Johansson para dictar una conferencia en España. Pasado mañana lo hará también en Barcelona, en Cosmocaixa, y yo quiero dejar testimonio de que hoy es un día de una excepcional importancia en la historia de este museo. Muchas gracias.
Enrique, thank you so much for a lovely introduction. But I want to thank all of you before we talk about these old bones, to thank you for coming tonight, to come and hear about my oldest girlfriend, Lucy. You know, he said that I love fossils, so now you know the age of my girlfriends. But also I want to thank the mayor for being here and the support of various people who have arranged for me to have this extraordinary opportunity to be in your wonderful country, about which I am learning more and more wonderful things every minute I am here. And of course, my great friend Juan Luis Arzuaga, and the extraordinary discoveries that he has brought to the world of paleoanthropology from the Atapuerca region that have opened up an extraordinary new vision about early humans in Europe. And you should all be very proud of what is being discovered in your country, because what is being found is helping us really understand the antiquity of humans in Europe, what kinds of species were here, and how they lived and survived over hundreds of thousands of years. This afternoon, or this morning, I had a remarkable opportunity to go with Enrique to see the site in the Valley of the Neanderthals, which I think will also bring us a better understanding of who the Neanderthals were, how they lived, and how they may have actually had a very interesting symbolic life. And that's just to make you interested, because traditionally we have thought of Neanderthals as not very intelligent. And I think that some of the discoveries that are in this museum at this moment, which I had the privilege of seeing before I came out here, and fossils that will be found in the Valley of the Neanderthals, will add enormously to our understanding of human evolution. I must say that I have had such a warm feeling arriving here just yesterday. I feel like I've been here most of my life, because everyone has been so nice and welcoming to me. And as he said, this is a red letter day, my first major presentation in your marvelous country. And I think I can say that I hope that I will be invited back again in the future. I have had a very rewarding life, extraordinarily rewarding life, because I have been able to participate and try to answer the question that every one of us in this room has asked. Maybe the first question you ever asked your parents: where did I come from? We tend to think of parents and grandparents, and my parents came from Sweden, for example. But we're really interested as an introspective species, a species that wants to know about itself. Where did we come from? What is the scientific explanation for why this species, Homo sapiens, has become the dominant species on the planet today? What was the evolutionary journey like? We weren't mysteriously created in one day. We were created over perhaps 6, 7, 8 million years. And what is exciting about that is that the geological record, predominantly in Africa, has preserved many of those fossils that help us reconstruct this incredible evolutionary journey. And I'm also very fortunate because when I came into this field, when I decided that I wanted to search early humans, I came into the field at the right time. Historically, Enrique and I talked today, driving back and forth between the Valley of Neanderthals and Madrid, about how history and the political world and so on of scientific discovery is so important to understand completely why things happened at particular times. And I was very fortunate because when Clark Howell, who you heard mentioned, who was my professor at the University of Chicago, brought me to Africa in 1970. I was only 5 years old. No, so obviously I was 27 years old. But when he brought me there, the field of human evolution had about 6 species. Today we have maybe almost 25 different species of human ancestors. It was a time when very ancient fossils were unknown, and we were unable to understand the evolutionary relationships between those fossils. It was a time when opinions were incredibly different depending on what scientist you spoke to. And I feel fortunate because I came into the field at that time and have been participating in that field for the past 46 years, which is a long time. It's more than many of the young students in the room can even think of. You know, we had electricity, we had telephones. And I've had this great privilege of watching the field grow and being part of that growth and contributing to that growth. And it's been very rewarding for me as a scientist to be part of the momentum of what has happened over the last 46 years, which is very different from what I studied in 1970, for example, at the University of Chicago. I also feel that people everywhere, of course, are interested in themselves and how they got to be who they are. And I think we are, in some ways, and I'm, of course, not the first person to say this, but I think that the species, Homo sapiens, all of us in this room, I didn't see any Neanderthals come in, are at a point in our evolution where we have to begin to think very differently about who we are and what our responsibilities are on this planet. We are the most intelligent. We are the most powerful. We are the most innovative. We are the most destructive. We are the most creative. And I think the stories and knowledge that we gain from our past have very important messages for us as a species as to where we go in the future. And I will talk about those again when at the end of my presentation this evening. But I wanted you to think about that as we look at these, because these certainly are inanimate objects. You know, they're cold fossils. They're dead. But they were alive once. And they lived in a natural world. And we are moving, I think, very dangerously more and more away from the natural world. And we are thinking of ourselves as separate from the natural world. But as Darwin and others, and particularly myself, I think that we have to be reminded that we are part of the natural world, even though we all carry iPhones and smartphones and so forth in our pocket. but we are still part of the rhythm of the natural world. Now, the Lucy story is, of course, my story, but the Lucy story is everyone's story because she has brought so much attention, as you heard in this wonderful introduction, to the study of human origins. It's not an esoteric study that a few people in the world are doing in some dark university somewhere. It's something that concerns all of us. So Lucy's story is as much my story as it is your story. And I will tell you a little more about that. Now, for those of you who use Twitter, there's a couple of hashtags you might want to use. But over the last, maybe can we bring these lights down a little bit? Is that possible? We have a pretty good picture of the last 6 million years or so. We know 6 million years ago, our ancestors had small brains and big faces, like African apes. That's good, yeah. And that through time, the faces reduced and the brain grew until we see the emergence of all of us, Homo sapiens, about 200,000 years ago in Africa. So we have the broad strokes of a picture of that evolutionary journey. And what we are trying to do, Enrique, Juan Luis, myself, and many other paleoanthropologists, are to find the details that will fill in the architecture of the human family tree. Charles Darwin, who everyone, I think, has heard of in this room, was an extraordinary man in many ways. Because when we think of ideas, Darwin had one of the greatest ideas of the human mind. He knew nothing about genes. He knew nothing about how features are inherited. He didn't know the molecular level of evolution, but he came up with what I call the grand unifying theory of biology. And what I mean by that, and that is what we call an enormous change, a revolution in thinking, a total revolution in thinking which changes everything 100%. He did this by leaving England once, by sitting in his home outside of London, and looking at the natural world and understanding that there was something that united that whole natural world, that diversified that natural world, which he called natural selection. And in 1859, he published this revolutionary theory. It's a real, we use this term, paradigm shift. Everybody uses it incorrectly, because a paradigm shift is where you go from the Earth being at the center of the universe to things going around the sun, not us. And that's what Darwin did for evolutionary biology. The other thing that is, when we think about great minds and great ideas, the other thing he did is that the grand unifying theory of biology is still the same today as it was in 1859. So natural selection is still the explanation we use today in spite of 150, 200 years. So he created something. He didn't know exactly why, but he was able to deduce from the observations he made because his mind was open. And he did it at a critical time in the 19th century in England, which was a very strict religious country. And he faced great opposition. He wrote very little about human evolution in his book. He simply wrote, "Light will be thrown on the origin of man and his history." Some sort of accent like that. Yet that was enough to make people afraid They didn't want to be descended from the apes. They wanted to be very divinely created. Later in his life, he wrote a book entitled The Descent of Man, in which he brought his idea of evolution by natural selection specifically to human evolution. And even then, he had never been to Africa. There was not a single fossil found in Africa at that point. There were Neanderthals in Europe, of course, who wanted to be descended from a Neanderthal. But everyone thought that Europe was the finishing school for humanity, that that's where we really became human. But he took the contrary view, as did his friend Thomas Henry Huxley, who inspired me when I read Huxley's book when I was 13 years old, that talked about our closest relatives being the African apes, because we look like them, they have the same kinds of bones we have, the same number of bones we have, and so on. And they predicted that Africa would ultimately be the place, because our closest living relatives, like chimpanzees, this is a young juvenile chimpanzee I photographed at Jane Goodall's site in western Tanzania a few years ago. So Huxley and Darwin knew that we looked like them, that we had the same number of teeth, very similar teeth, same kinds of bones, the same number of bones. And we know from Jane Goodall's work that chimpanzees act a lot like humans, or humans act a lot like chimpanzees. I'm sure you've seen some of your friends on Friday night when they've had too much to drink or whatever, who may be acting sort of ape-like. We have somebody running for president in the United States who is very ape-like in his activities. And of course, the genetics of chimpanzees and the genetics of humans have been done, and we are about 99% identical. So there's no question today that these two creatures had a common ancestor somewhere in the deep past. This, to me, as a teenager, as a 13-year-old boy, was the most exciting thing that I'd ever read. And I went to my mentor at that time, who gave me this book to read, and I said, this is what I would really like to do. I would like to help understand the evolutionary journey of how we came to be. And of course, I knew that meant going to Africa. And discoveries had been made in 1924 by Raymond Dart of Australopithecus africanus, the tong baby. The famous Leakey family had been making discoveries at Olduvai Gorge. In 1959, they found a beautiful skull that really sparked interest in many different scientists, including my mentor, Clark Howell. And Africa is one of those very old continents that's been very much like you see it today for a very long time. It's been a great place of stability. But at the same time, it was a great place of opportunity. Because unlike Europe and Asia, which are from east to west, this is from north to south. You go from deserts in the north to tropical rainforests to deserts in the south. And natural selection was working in different ways in different parts of that country, that continent. And there were apes. There were many kinds of apes. There were probably hundreds of species of apes. Like today, there are 100 species of monkeys or something. And almost all of them died out. If you look at the trend of evolution from 40 million years ago, 30 million years ago in Africa, they all died out, except for the chimpanzee, the bonobo, and gorillas, and the naked ape, the upright ape, us. So this poses for us a whole series of very interesting questions about how did this environmental diversity and instability over time create who we are today. That's the ultimate question that we all want to try to answer. I began working in southern Ethiopia in 1970. That was one of the most exciting years of my life. I was a student living in Chicago, and I was invited to go to this place that I had only read about and heard about. And I will never forget getting into a small airplane in Nairobi. I had just arrived from Berlin to Nairobi. And my professor, Clark Howell, was in Nairobi at that time. And we were in this single-engine airplane, and we were flying up to Ethiopia, up the Great Rift Valley, up through past Lake Turkana, and we landed here in a desolate, almost forgotten southwestern corner of Ethiopia in the Great Rift Valley. And my first night, as you can imagine, sleeping in a tent and listening to the hyenas, I was in Africa. And it was exhilarating. It was the most exciting moment for me to think, I am in Africa. And my career started there. I never found a human fossil. I thought you would just go out and you would say, aha, but they're very, very hard to find. Then I was in Paris because there was a French group of scientists, and I met a geologist one night at a party, a Frenchman, and he was very excited. He said, we have the fossils in the affaire. C'est vraiment quelque chose, you know. He says, you think you have the fossil in the Homo, huh? No. So he invited me to go to This is a little bit nicer. You see the river, you see the camp with, these are our showers, this is our working tent, this is our dining tent where we eat breakfast, lunch, and dinner together. You have to like each other when you go out for 2.5 months. And you are with each other at breakfast and lunch and dinner. There's no place to go. There are no diversions, there's no cinema, there's nothing. And this is the kitchen. These are tents people lived in. And we use that as our base, Camp Hadar. It's not the safest place in the world. People ask, with such a productive and important site like Hadar, how do you keep your colleagues from stealing that site? Well, they have to meet these guys first. But there are lions that wander through here. There is a rival tribe that lives across the river that has sometimes used their AK-47 shooting over our camp. And these were the local people, are the local people. I think this is the only one who's still with us. These are nomadic Muslim tribesmen, and they still carry these Kalashnikovs today. And they have been part of our expedition ever since we put our tents in their front yard and said, do you mind if we work here? And they have gotten so interested in the work we do. And I will tell you a little bit more about that, which is a fascinating story. So yes, here I am, just there. And I would not be here today if it was not for hundreds of people who have worked on this expedition since 1973, right on up to 2 years ago, and we're planning to go back next year. But you have a wide array of geologists, paleontologists, people who study fossil pollen grains from plants that fossilize also. You have people who are experts in dating the rocks. You have people who specialize in fossil pigs. Yeah, some people do that. Other people who are specialists of antelopes or whatever. And we all share a common fascination with this question of who are we, where did we come from? And it's because of the incredible ingenuity and dedication of these people that I can tell you what I'm telling you this evening. Now, of course, we have electricity because we have solar panels. And here you see some of the people just after dinner sitting and talking, and some geologists working in the tent, full moon at night. When I first began there, I always say it was much more romantic. You know, we had little kerosene lamps. We didn't have iPhones. We didn't have email. You waited for the mail to come. You'd write a letter to someone, and maybe a month later you would get an answer. Now it takes, what, 2 seconds? But once you are there, and once you are living there, and once you establish your connection to that land and to the unbelievably beautiful African sky, you don't want to leave. You don't want to come home. You stop reading the newspapers that people bring in. You stop listening to the BBC on your little radio. You are so happy being in what we would really call civilization. So here is one of these beautiful fossils. This is an elephant foot that's eroding out of a geological stratum where it died, in this case, 3.2 million years ago. And it's pretty complete. As you can see, it has the toe bones and the ankle bones and so on. People always say, how do we find these fossils? Well, the only way to do it at these kinds of sites is to walk and look and look and walk and walk and look. So you have people surveying here, hoping to find something before the next rain comes and washes them away forever. a team like this just last month, right? No, earlier this month. No, last month, September, right? This is Zerai Alamseged, who is a paleoanthropologist, an Ethiopian, one of the first ever to lead his own expedition in his own country. He found a complete baby skull, but he was training with us. And they might spend, 3 days in that little basin, just looking and walking and looking and walking. And there's no magic way to find these things. Sometimes it begins with the discovery of a simple molar tooth like that. You see a team here which is screening the loose sediments. That tooth was found here. This is Bill Kimball down here, director of the institute where I work in Arizona, and a geologist up here and a team looking for other pieces. This resulted in a complete face of Lucy's species. And it took one person, after looking for days in this area, to find one molar that added an important understanding of what Australopithecus looked like. This is the well-known site of where Lucy was found. Where you see people here was where the first piece was discovered, where I found the first piece of bone. It was a Sunday morning on November 24, 1974. It's interesting, Darwin's Origin of Species was published on November 24 in 1859. And I was out with one of my students because we had to mark some fossils that had been found. And we didn't find very much. We walked here, not a very big area, maybe twice the size of this beautiful room. And we found a piece of antelope and a little piece of baboon jaw with a couple of teeth in it. And we're walking. And now it's, 40 degrees or 42 degrees, and I'm thinking of going for a swim in that river. But I always look at the ground. And he was on my left, and I looked over my right shoulder and saw a little piece of bone, gray piece of bone. And that piece of bone was this. Doesn't look like much. It's a little piece of elbow right there. It's what allows you to flex and extend at the elbow. It's a little notch. And I knew from my studies of anatomy and comparative bone studies and so on that this was not an antelope. It was not a baboon. It was too small to be any kind of a large mammal. And I had an instant sense that this was part of a human ancestor. And as I looked up this slope here, you see the markers. There were pieces of a jaw, pieces of a skull. There were ribs. And I realized that this was part of a skeleton, of a person who had lived, we now know, 3.2 million years ago. And this is the next day when we are out. That's me in the background, much thinner and younger, and not quite as much like a old gorilla with the silverback gray hair. And of course, that's my graduate student who's doing all the work, of course. And yes, that's toilet paper we're wrapping the fossils in, because it happens to be very good for that, and other things. And so this locality yielded parts of a skeleton, 3.2 million years old, that was revolutionary, I think was the word that Enrique used. An enormous amount of effort went into processing the loose soil. It was screened like this in the field. That was collected in buckets, and then it was washed with water, so we wouldn't miss the tiniest flake of bone or chip of enamel. And this is Maurice Taïeb, he's a wild Frenchman, who had the idea to go to this terra incognita to do geology, and who recognized these fossil bones and brought them to various people's attention, and particularly mine. And it's the first time when we were beginning to assemble. You can tell this is 1970s. Look at the sideburns here. Long sideburns. The time of the Beatles, of course, and lots of other wonderful things. And it was the first time we began to take this person, who happened to be named Lucy, not because we knew what her name was, but because somebody on my expedition, I had a girlfriend, and her name was Pamela, so we didn't call her Pamela, but the song, Lucy in the Sky with Diamonds, was playing in our camp when we were celebrating. And Pamela said, "Why don't you call her Lucy?" I said, "I'm a scientist. I don't give cute names to my fossils." And it was too late. Because as soon as the word was uttered, said out loud, she became Lucy. You couldn't change it. The next morning at breakfast, are we going back to find more of Lucy's skull? Are you going to the Lucy site? How old do you think Lucy was when she died? You could not put it back into the lamp. Once the genie was out, once the name was there, it could not be changed. And Maurice and I were just putting the skeleton together. And what an enormous reward for, of course, personally, it changed my life. This was a defining moment. When I think back, this was the defining moment of my life. I was 31 years old. I had just gotten my PhD at the University of Chicago and told my professors, I'm going to Africa to find something. And I did. But Maurice, who in his generosity to include other people on his expedition, this was a reward of his great generosity. This is, of course, a very familiar picture, especially to Professor Arsuaga's students. Where are you? Are you here somewhere? Ah, you're going to get good grades. You know those students? They're here. The other people are not. But this is roughly 40% of a skeleton. It's 3.2 million years old. At that time, if you went to the national museums in Kenya, you would find about 4 specimens you could put in your hand that were older than 3 million. We knew nothing. I felt, of course, when I first looked at the teeth, that it was this tongue twister, Australopithecus, but I didn't know what species it was. That didn't come until we named her in 1978, Australopithecus afarensis, after the Afar region and the Afar people. It's extraordinary to have upper and lower limbs, that these are very relatively short lower limbs. These are relatively long upper limbs, probably reflecting the time her ancestors spent in the trees. And long before natural selection lengthened our lower limbs, making a long lever arm for locomotion, making it more efficient. You use less energy. We have a strange mode of locomotion because if you think about it, no other mammal walks on 2 legs. No other mammal slips and falls, right? Your family dog has 4 legs. He's smart. We only have 2. So it's a very unique and strange mode of locomotion, of getting around. But obviously, with 7 billion people, it was pretty successful, apparently. We had the pelvis, which was extraordinarily important because that is really the center where the upper and the lower body meet, and where there is a complete rearrangement of muscles and the biomechanics of the hip that allow us to walk upright. Unfortunately, we only had fragments of the skull, which were washed away, enough to reconstruct the size of the brain, about the size of a big orange, very small, 380, 400 cubic centimeters, about the size of a chimpanzee, and many other details. And Professor Aswaga wanted me to mention this sort of angle at the knee, where the femur comes up like that, the bicondylar angle that tells you immediately that she was upright and bipedal. So when she was announced in November of 1974, because the Ministry of Culture from Ethiopia came to visit, and they brought newspaper people with them, which really surprised me. And she attracted great attention, not just from scientists, because she wasn't just a number. You know, she was like a personality, but also from the general public who are interested in this question, as I've said several times. And she's become a touchstone or a benchmark for people who read about a new discovery from Africa in their newspaper. And they always say, a new skull older than Lucy was discovered in northern Kenya, or a skeleton more complete than Lucy was discovered in Ethiopia. So she is the discovery by which the scientists and the generally interested person begin to judge other discoveries. She's become part of our common talk. Here is a paleo cocktail party, and she's being introduced, and it says, not the Lucy. And she's in our crossword puzzles in the United States, where you get a clue about an early human ancestor, 4 letters, begins with L. So people know who Lucy was. In Ethiopia, strangely enough, because she's known as Dinkinesh, which is an Ethiopian word which means you are beautiful or you are wonderful. But people in Ethiopia know her as Lucy, and you have things like the Lucy College, the women's soccer team, international women's soccer team from Ethiopia is called the Lucy team. So they're very proud, obviously, of this discovery. And in 1985, the Ethiopian government issued this stamp, and there is her Ethiopian name, Dinkinesh. And this is reconstructing the missing parts, pretty much what she would have looked like, the ape that stood up. She walked like us. She didn't talk like us. She had a very small brain, but she was an important discovery bridging the more ancient fossils with more recent fossils. Now, there was a great deal of controversy. You know how academics are. We love to disagree with each other and to challenge other people's ideas as to whether or not Lucy really walked upright, or did she walk like this, bent-kneed and bent-hipped. Well, next time you go out carrying something heavy, try to do that, and you'll be exhausted. And we predicted on the basis of the pelvis and the knee and the foot that she was upright. And one of the people who came to visit me in the Afar was the late Mary Leakey, who had worked at Olduvai Gorge with her husband, Louis Leakey. And Louis and Mary worked at a site, a location, just off the Serengeti in 1939, a long time ago, called Laetoli. And they found fossils, but there were no tools, and they thought there couldn't be humans there. But because I had made these new discoveries in Ethiopia, Mary thought back to that site and decided to go back. And when they went back, they found jaws and teeth that are identical to the ones we were finding in Ethiopia. But more important is they found a trail of human footprints. What could be better to solve this argument? To have footprints in a soft volcanic ash. There was a volcanic eruption, and the Ash came down like snow, and these animals, including elephants, giraffes, rhinos, antelopes, etc., walked and left their footprints. And the volcanic ash was wet because it was raining. How do we know it was raining? Because we can see the raindrops. And then then the sun came out, and it dried this like concrete or cement or plaster of Paris. And there was another eruption, and it preserved these for 3.6 million years. So we know that Lucy's relatives were walking here. What did their footprints look like? They looked exactly like the footprint that you and I leave when we walk on the beach in our bare feet. There's the big toe. These are the lateral toes. This is the arch of the foot and the strong strike of the heel. So this is one of the great wonders of the paleontological world you're looking at, these footprints. Well, Lucy was certainly not alone. I've just finished writing an article to be published next year. We now have over 400 specimens from her species, many more than you see in this picture, many more. We also have complete skulls of a male and female. We know that males were much larger than females, that there was a lot of what we call sexual dimorphism, and that males were significantly larger than females for a number of reasons. And there are many new discoveries which have not even been published by other teams. And what is important about this is that we have a record of a fossil species over 800,000 years of time in Tanzania, Kenya, Ethiopia primarily, and perhaps also in North Central Africa and Chad. So this was a long-lived species. We've been here 200,000 years as probably who we are today, maybe only about 100 or 150,000 years. Yet Lucy's species lived for 800,000 years and went extinct there also, I think. This is a complete female skull of her species, so we know now pretty much what they look like. And you have in your country one of the greatest reconstructionists, Maurizio Anton, who will be with us in Barcelona, and I'm sure that many of you in the audience have seen his reconstructions. I met him for the very first time recently in Tbilisi, Georgia, and he reconstructed what Lucy looked like holding the baby that was found by this Ethiopian scholar. And they look very ape-like, which is true. But they were already launched in a direction that would give rise to all of us today. They lived undoubtedly, this is Jay Maternis, who's another wonderful paleo artist. And they lived in groups. They were probably living in more forested areas rather than open areas. They were primarily vegetarians. They ate, I think, to a large extent, fruits, but they also ate things like termites and ants and turtle eggs, crocodile eggs, and so on, birds' eggs. And when I published or announced Lucy as a new species, Australopithecus afarensis, in May of 1978, it generated a huge discussion about where does this species place on the family tree. And here is afarensis between 3 and roughly 3.8 million years. And I'm not going to go into the details, but I published several articles myself and with colleague Tim White at Berkeley, and we hypothesized that this was an ancient species of human, generalized, that would possibly have given rise to later Australopithecus. This is like the kind of skull that was found at Olduvai by Mary Leakey in 1959, and also to the human genus, Homo. And when I presented that paper in Sweden, there was great controversy because there was 1.2 million years between this and these. And they said, you have no evidence. And I said, I know I don't have any evidence, but I think that this is one good hypothesis. That's the important thing about a theory, like evolutionary theory, is that it makes predictions. And those predictions will be proven right or wrong with new discoveries. Okay? So what happened? Well, in 1985, Richard Leakey's team at Lake Turkana found this cranium, which was called Australopithecus aethiopicus. It happened to be 2.5 million years old. It had a projecting face, enormous teeth, and a crest. The big projecting face tied it with Afarensis, and the big teeth and the crest tied it with its descendants. So that seemed to be pretty good, that we had some evidence for this lineage. But what about the Homo lineage? We still had 1.2 million years of time missing. Homo fossils are very hard to find. Well, in 1994, my team at Hadar found stone tools associated with an upper jaw, a maxilla. This is the shape of your jaw, or my jaw. This is the shape of a chimp, a rectangle, like Afarensis. This shape is very much like our own, and there are many other features. This was 2.4 million years. That still left 600,000 years back to Afarensis. Well, fortunately, a member of the Institute of Human Origins, Kay Reed, led a team to a site that I reported way back in 1972. Just here, here's the Lucy site, just there at this site, and the strata are 2.8 million. And our Ethiopian student, our current student at the Institute, made this discovery of a little half of a jaw. And when you look, this is where the jaw was found, just on this ridge. And if you look at these molars, they're very long and very narrow. And there are a whole bunch of features in this jaw, which I'm not going to discuss, but there are many features in this jaw that are classic for our own genus Homo. And yet there are features in the shape of particularly this symphysis, this area in the front of the jaw, that are like Afarensis. And it's 2.8 million. So what we have now, well, here you see, this is an Afarensis mandible or lower jaw. This is a Homo jaw, quite different. So what we have now is Homo at 2.8 and 2.4 that forecasts later species, as you heard, like Homo habilis. So this is my current working hypothesis that was premised on our earlier discoveries that is now being tested by new discoveries. One of the biggest misconceptions of human evolution, and you see this in your newspapers and magazines all the time, is that it was a march from something ape-like to modern humans, that it was a direct line. Even Darwin knew it was branching. There were many branches that died out, as you well know if you study this subject at all. But what really upsets me and my students is, why is the pinnacle of evolution always a white European male? It's because white European males are the ones who draw these. But I looked long and hard on the internet and found at some Spanish site this illustration that also reminds us that women too have evolved. And maybe a little bit more than males. But at any rate, this is a great misconception of human origin. I show this. I don't expect you to know all the names, and there are species missing. But the human family tree, like the family tree of any animal, any plant, any insect, had many false starts. And many things went extinct, as you can see. Even Neanderthals. We have a little Neanderthal DNA, but we are the one species. And here is Afarensis again to remind you. And of course, here we are, supposedly wise man. You know, Latin, Homo sapiens. We're supposed to be wise men. But I read the same newspapers you do, so I'm not sure that's a good name for us. I think maybe a better name would be Homo egocentricus, because we think of ourselves all the time. Don't you think about yourself more than anybody else? Okay? So, Afarensis, Lucy in shorthand, pivotal role at a critical place on the human family tree when climate was changing in Africa, and the emergence ultimately of Africa, of Homo sapiens. What's interesting to take away from this is that no matter what branch you grab on this family tree, the roots go back to Africa. So I don't like it when somebody calls Ethiopia the cradle of humankind, or South Africa the cradle. Africa was the crucible of humankind. That's where natural selection created us as we are today. Ethiopia has been extraordinary because we have a fossil record from 6 million years right on up to the emergence of Homo sapiens. It was one of the unnoticed places from which we have retrieved some of the most important evidence about the earliest parts of our human origins. So what kind of message does Lucy bring to us? She was fossilized in this layer, in suspended animation for 3.2 million years, totally anonymous, until she eroded out and I found her. And I think we call these things, I call them, they're links to the natural world. They remind us of the fact that it was nature, it was Mother Nature, through the process of natural selection, that really created all life. And that when we make discoveries like these, they link us back to a time when we were deeply embedded in the natural world. We think today, and it was a big argument I had when I guess I was 20 years old in an anthropology class, and we had a textbook written by a fellow named Kroeber, and he called humans super organic, above nature. And I said, we can't be super organic. You cannot have 6 million years, I didn't know it was that long, but you can't have all of this evolution and then just step out of nature. We know today, from the way that we are mistreating this planet, that things are happening. This is not some mad scientist saying there's global warming. You talk to people in the Maldives who walk out one day and half their beaches disappeared because the oceans are rising. You talk to people who can no longer grow crops, and so forth and so on. That what we have done to this planet has been largely destructive. We have taken so much from this planet, and it's time that this species begin to think, as I said earlier, that we have stop thinking as if we have another place to move to. There's no other place to move to. We barely can make it to Mars. Take forever to have something to live on the moon, for example. This is where we have to be. This is where we live. And it's not going to be very nice unless we start reinventing a reverence for the natural world and start taking the responsibilities that we have responsibly and look after our planet so that we as Homo sapiens, instead of being Homo egocentricus or Homo destructiveness, that we make plans and make the right choices so that we as a species will leave descendants our children and grandchildren and so on, who will look back on their ancestry. And it's time that this species begin to understand that it is really our responsibility. We are not at the top of the pyramid of life. We are in the middle of that pyramid. And whenever we disturb the natural world around us, it will come back to disturb us. It's a very important message. Thank you very much. Thank you. Thank you. Do you want to? Okay. Thank you. Thank you so much. Can you hear me? Yes. Is this working? So I'm not too worried about the questions because we have two experts if I can't answer them.
Bueno, lo digo en español, ¿no? Vale. ¿Qué opinas sobre el descubrimiento reciente relativamente del Homo floresienticus o algo así, que ha trastocado un poco la cadena evolutiva que se pensaba sobre, sobre el Homo y que no está muy claro hoy en día sobre qué es, de qué ha evolucionado y todo eso?
We have a wonderful translator, I think. Are you going to try? I don't have my machine on, yes. Sorry, Alex. Yes. All right. Thank you. No, technology is complicated.
¿Cuál es su opinión sobre el descubrimiento relativamente reciente del Homo floresienticus que ha trastocado un poco la cadena evolutiva y que no está muy claro de dónde viene, ni de qué ha evolucionado, ni nada? Que es un poco, por así decirlo, un paso intermedio como me atrevo a decir que un poco como fue Lucy en el momento que no se sabía muy bien dónde venía.
It's a wonderful question. I visited a year and a half ago the island of Flores, and I went to the beautiful cave where this skeleton was found. And it's about 50,000 years old now. It's older than they thought it was. There are new dates published. And this is a skeleton which is about Lucy's size. Lucy was only 1 meter tall. I didn't mention that. And she was an adult because we had her teeth, and her third molar was there, so we know that biologically she stopped growing. But this Homo floresiensis, I really don't think it should be called Homo, but I think it should have had its own genus. I don't know what you think, but certainly it has a very small brain, about Lucy's size, and it's very short. And I think it was an early hominin that got isolated in an island and underwent this island dwarfism that made it smaller. I think it has nothing to do with later humans. And I think as we are beginning to find more fossils of different species, and also even DNA, like in Denisovans, that there were probably many, many species that we don't know because we haven't found them, or we are underestimating the numbers of species. Now, it was a big surprise to find this because it was thought to be, what, 12,000 years old or something, but now it's about 50. And when I read about it, I said, if we were studying lemurs that live only on Madagascar, and most lemurs are little things. They range from something that would fit in your hand to something about that size. And I read that someone found a lemur that was the size of a gorilla. I would say that's crazy. Well, they did find a lemur the size of a gorilla. So it's unexpected, but it certainly is something that shows us the diversity of fossils in fossil species in the past. And I'm sure there will be many other discoveries like this. But it is a viable discovery. I mean, the dating is correct. I don't think that it's really a dwarf or some kind of a disease. And it's interesting to look at how natural selection can bring about many different kinds of examples of even the human species.
Bueno, mi pregunta es para crear un poco de polémica entre investigadores. Es por interesarme su opinión sobre el Homo antecesor de Atapuerca. ¿Qué le parece la situación dentro de la genealogía humana? Y si está de acuerdo o en desacuerdo con alguna de las posturas que tienen los investigadores españoles, porque en algunos árboles genealógicos le veo aparecer, en otros no. Bueno, se trata un poco de esto, nada más.
Well, we don't have a lot of specimens of Homo antecessor, but in my opinion, it is clearly a different species and should be on our family trees. I believe it was on my family tree. So I think that what is being found in Atapuerca, as you go deeper, is the documentation that earlier species than we ever thought got to Europe and gave rise to later things. And I think that the DNA work that's being done on many of the fossils is also showing us that you have a good example of proto or very early Neanderthals there. And the kinds of fossils that are being found and dated and studied and examined with new methodologies like DNA are bringing about a significant revision of the genus Homo in Europe.
My question is about from the time you found Lucy to nowadays, all those fossils have been found in those days. They fit in your main idea about evolution, or they make you change about your primary idea of this evolution? I mean, I don't know if I'm...
Well, when we first made those discoveries, beginning in '73, we thought they represented maybe 2 or even 3 different species, because we had very big ones and we had very small ones. We had very primitive-looking teeth. We had more advanced-looking teeth. And when we began to find all of these, over 400 specimens, we found that there was a sort of a normal range of variation, and we put them all into a single species. And by doing that, and recognizing that Afarensis was an ancestor to Boisei in East Africa, or Nutcracker Man, the Olduvai discovery, we re-examined all of the South African fossils from the cave sites in the Transvaal, such as Africanus and Robustus. And it became clear that since probably the 50s, we thought Africanus was the ancestor to Homo. But having this new perspective with this more primitive species that was not as specialized as Africanus, the Tong baby, that you'd have to have something that evolved in the direction of robust Australopithecus, and then to undergo all those changes to be an ancestor to Homo, which we don't, these evolutionary reversals are very rare. So it gave us a new impression, or a new geometry of the tree, which was very important. And I think what we're seeing now with new discoveries of species, I think that Australopithecus sediba, do you know any of these? Is probably an immature Africanus. I think that Berger and his team made the classic anatomical error of comparing an immature specimen with an adult specimen. There are a number of researchers in Switzerland at the meetings 2 years ago who suggested that the growth trajectory from infant or teenager to adult would make sediba an Africanus. And I think that that's the case. And the new material from the, Rising Star Cave, which is put into Homo naledi, nobody knows what this is. It's not dated. It's going to have to be very, very old, older than 3 million if it's an ancestor to Homo. And the other thing it did for us and for me was it got me thinking that maybe South Africa and East Africa are different, totally different arenas of evolution. You never find the same species of human in both places. You find different species of pigs, different species of antelopes, and maybe there's no connection whatsoever. So it brought about a lot of changes in my ideas, and I think within the field of paleoanthropology. So it's an excellent question.
Una última cuestión. Aquí tenemos.
Before everybody leaves, I just want to thank you so much for coming tonight and being here. It was a wonderful experience for me to have such a marvelous audience. But I think we have one more question.
Sí, gracias por su intervención. A mí me gustaría saber si usted ha participado también en la búsqueda de pistas sobre su manera de vivir y si se sabe cómo vivían y cómo se estructuraba su sociedad y se ha encontrado en Etiopía o en otros lugares en África.
Yes. These creatures, Australopithecus afarensis, are all really, as far as we can tell, there's a possibility there may have used some natural rocks, but they're really pre-cultural animals. I think in terms of behavior, that we should look more towards how African apes interact with one another. That they were probably living in troops of anywhere, I don't know, 25, 50 individuals with males and females. I think that males were predominantly large because they were large to protect the group. But beyond that, there's very little that we can say. We can say one thing that's interesting is that we find afarensis over 400,000 years at Hadar. The climate goes from closed to open, closed to open. Yet the species did not change. So this was a very generalized species that could adapt. It was highly adaptable. You know, if you were a very adapted creature and the climate changes and you cannot change, you die out. But I think the importance of afarensis is that it was a highly adaptable species. That if the climate changed and the vegetation changed and the constitution of animals that it lived with changed, it could still survive. But once you get to a specialized, very specialized form of Australopithecus, like Boisei or Robustus, when they received competition for food and territory because of climate change, they could not make that change and they died out. So that's really the important lesson for somebody who's in business, who you know, what happens is you make one little thing, right? And then somebody in China makes it for 5 cents. And you can't change you're too specialized. Your company goes, obviously, bankrupt. Well, that's the important thing about the human species sitting here tonight. We are very adaptable species. And today we do it through cultural change, essentially, rather than genetic change. You know, if the glaciers come back to Northern Europe, people aren't going to start growing hair. They're just going to turn the heat up and wear more clothes. So I think, but it is important as we as individuals think about the world, that we have to teach our younger individuals to be adaptable. And that's why problem solving is so important. So I think it's an important lesson that Afarensis was highly adaptable, and these other species were much too narrowly adapted and faced extinction. So I thank you again. Thank you very much.